So with this next unit, we have skipped ahead some chapters and are actually working in chapter 7. And then we will be coming back and doing some other sections. What we're going to be doing in chapter 7 works with similar triangles. So some of the things that we will talk about relate to that congruency chapter that we just finished up. So that's why we have rearranged things because you're going to see some connections to things that we did in our previous unit, which you guys just did great on. So today in this first section, we're going to be talking about ratios and proportions, which is basically a review of some things that we did in algebra. So if you open up the ratios piece in your interactive notebook, it says what is a ratio? It is a comparison of two or more quantities. A comparison of two or more quantities. So there are 3 different ways that a ratio can be written. So this is just some examples. One way that you can write a ratio if you are only comparing 2 quantities is with the fraction bar. Okay? So that really is what a fraction is. A fraction is a comparison of 2 or more quantities. So we could write a ratio as 4/3. Ratios can also be written with those quantities being separated by colons. Okay, so if we're just comparing 2 numbers, we could separate those 2 numbers with a colon. Or the other way that we can write them is using the word 2 in between them. So 4, 2, 3. So again, different ways that ratios can be written. Lots of times, because if we're using them in a calculation, many times we will use this fraction form. We're also going to be looking at how we can use with the colons. And then the last thing to remember about ratios is that they must be simplified. So again, especially when we're working in that fraction form, okay, we're not going to use a decimal. A ratio is not going to be written as a decimal. So we need to write it as a fraction. It needs to be in simplest form, so we need to reduce it if possible. We do not write it as a mixed number. Okay, not as a mixed number. So that's basic information about our ratio. On the right-hand side, then, we have an example. So we want to write the ratio in simplest form. It says the football team played 62 regular season games last year. We're not talking high school here if they played 62 games. If they won 34 games, what is the ratio of wins to losses? Key thing to be careful of with ratios is order is important. Okay? They went wins to losses. So that means wins goes in the numerator, losses goes in the denominator. Okay? So oftentimes when I set up my ratios, I like to write it in words first. So I make sure that I'm not just pulling out numbers and throwing them together. So how many wins did I have? 34. How many losses did I have?
28.
28, and how did we find that?
62 minus 34.
Okay, 62 minus 34. Okay, so that's why it's very important to read, because a lot of people that don't read, they would have just wrote 34 over 62, which would be wrong. Okay, because it's not total games, it's wins to losses. So again, we said 28 losses. We need to simplify that. So what can we do to simplify that?
Divided by 2.
Divide by 2. I get 17 over 14. Is that in simplest form? Yes, it is. Okay, so that is my answer.
Dang.
Next piece down is what we call an extended ratio. Okay. When we worked last year in algebra, our ratios were always just 2 terms in the ratio. With geometry, we can use what we call an extended ratio. An extended ratio is still a comparison, but instead of being 2 or more quantities, it is 3 or more quantities. So when we look at how that comparison or that extended ratio is written, we cannot use the fraction form because it's going to have 3 or more numbers in it. So we can't write it as a fraction. It's going to be given using that colon. Okay. So an example would be 3 colon 4 colon 7. And again, it could be more than 3 terms. But again, that extended ratio is just going to be more than 2 terms, 3 or more. So we're going to separate those numbers with those colons. Okay. So if we can't write it in a fraction form, we need to look at how we can use this information and still be able to do a problem with it. So we'll see this in the example on the right. So with these extended ratios, you need to, again, look at the entire problem and think geometrically, what do I know about the situation? So this one says the ratio of the measures of 3 angles in a triangle is 3 to 7 to 10. They want us to find the measure of the largest angle. So when I just focus on that 3 angles in a triangle, what do I know geometrically about 3 angles in a triangle? They add up to equal 180. Okay? So I have to have 3 things that I have to add together to equal 180. Okay? The only thing that I have is this ratio. So with this extended ratio, I'm going to take each one of those terms and I'm going to put a variable with it. Okay? So I'm going to do 3x plus 7x plus 10x. And I'm going to set it equal to 180. Okay? This does not mean that every time you see an extended ratio, you're going to add them up and equal it to 180. Okay? It depends on the situation. Okay? This is 3 angles in a triangle. So we know that's what those angles do. Okay? What you are always going to do is take the extended ratio, put the same variable with all of the pieces. Okay. So now I'm going to combine like terms. So I've got 20x equal to 180.
9.
And that second one. Okay. So I'm going to divide both sides by 20, and I find that x is equal to 9. The question, though, wants me to find the measure of the largest angle. So what am I going to do to find the measure of the largest angle?
Plug it into 10x.
Okay, the largest angle would be my 10x. So 10 times 9 is 90. They wanted all of the angles. My other angles would be 30 and 70. I'm sorry, not 30 and 70, 27 and 63, taking it times 9, and they, again, would add up to 180. Okay. So with extended ratios, we're going to have to come up with some sort of an algebra equation that we can then solve. And then the last flap is the proportions. A proportion is an equation that states two ratios are equal. An equation that states two ratios are equal. So in this situation, when we're going to set two ratios equal to each other, we're looking at that fraction form. So we're going to have two fractions equal to each other. So, for example, A over B equals C over D. Fraction equal to a fraction. So who remembers from algebra, if we have a fraction equal to a fraction, how do I solve that? I have a variable. One of those terms is a variable and the other three are numbers. Not reciprocal. What were you saying next?
Flip the D and the C and then times it.
What do we do to solve a proportion? There we go, cross multiply. Okay. So if we cross multiply, okay, that means I take A times D equals, cross multiply the other direction, B times C. So to solve a proportion, we cross multiply. So we have a proportion now on the right-hand side, and we need to cross multiply to solve. Something that I said last year in algebra, when we're going to cross multiply, this entire quantity, x minus 9, even though there's two terms, it represents one number in that numerator. So that x minus 9 has to stay together. So when I cross multiply, I have to take both of those terms and multiply by 10. Okay, so I have 10 times the entire parenthesis, which means I'm going to have to distribute. Equals, when I cross multiply the other direction. Again, that 2x minus 9 represents one number. So I have to take 15 times the entire parenthesis. So when I go back to this left side and distribute, I get 10x minus 90 equals, on the right side, I distribute 30x minus 135. Got a variable on both sides. This is where I want to start by getting rid of the little guy. So I'm going to subtract 10x. Okay, if my x's are going to be on the right side, that means I need to get rid of that 135. So instead of subtracting 135, I'm going to do the opposite and add 135. And then I need to finish it, so I am going to, whoops, I didn't add correctly over here, because I had a negative 90, not a positive 90. Okay. So negative 90 plus 135 is 45. So then I divide both sides by 20. And I need to simplify. So what can I do to simplify? What'll go into 45 and 20? 5 goes in. So 5 goes into 45 9 times and into 20 4 times. So x is equal to 9/4. Okay? And we're going to leave it in that fraction form. Do not change it to a decimal. Okay? The only time that you would change it to a decimal would be if we had some sort of a word problem, right? And they're wanting to know a quantity of some kind. They want to know how many cars or something like that. We would change it to a decimal. Okay, but if it's just a basic proportion with variables and numbers, it's okay just to leave it in that fraction form. So that is it for this first section.